All right, welcome back. And now we're going to be dealing with trigonometry as I promised. So on the first question, 5.1, we are told that if cos theta is equals to negative 5 over 13, where 180 is less than theta and theta is less than 360, determine without using a calculator the value of. When you see such a question, what do? Immediately you draw a Cartesian plane here. And when you've drawn this Cartesian plane, now you must now come and say, I've been told that I'm working with cos theta, which is equals to negative 5 over 13. This negative 5 is my what? My negative 5 is the adjacent, and here the 13 is my hypotenuse. All right, that's what I know. Number 2, I've been given a boundary, and this boundary is saying that I'm going to work between 180 and 360. So this is 90, this is 180, 270, and 360. But, so in between these two quadrants, that's where we're going to be working. However, where is cos negative? Because check, it's a negative 5 over 13. Now, let's remember our cast diagram. C represents cos is positive, A, all are positive, S is sign is positive, and tan here is positive. So this has been ruled out. We are not going to work here. We are going to be working where? In quadrant number 3, because this is where cos is negative. Then we now draw this, and then we've got that. Now, where's the adjacent? This is where the adjacent is, and you can see that on the x-axis here, it's negative. So we've got a negative 5 here. The hypotenuse is always what? Positive, because it's distance. So here what we do not have from this angle theta, what we do not have here is the opposite, the length of opposite, the opposite side. All right, so very, very key. We've been told that we must work with the following without using a what? Without using a calculator, right? So now they want the value of sin squared theta, and it is got 3 marks. Now what do we know about sin theta? We know that sin theta is equals to opposite over hypotenuse. But remember, I said we do not have hypotenuse, which means now we have to use our Pythagoras theorem. So Pythagoras theorem states that hypotenuse squared is equal to opposite squared plus adjacent squared. In this instance, my hypotenuse is 13. So 13 squared is equals to opposite is what I'm looking for. So I said opposite squared plus my adjacent is negative 5. So I open the bracket, I say negative 5 squared. Now this negative 5, when it's inside the bracket, it gives us a positive 25. So and 13 squared gives us what? 169. So I've got 169 is equals to opposite squared plus 25. We're going to transpose the 25. It becomes 169 minus 25, which is equals to opposite squared. Now at this point in time, we are looking for opposite. So what do? Now we come here and we say 169. Oh, okay, no problem. 169 minus 25 is 144. So we say 144 is equal to opposite squared. But we are looking for opposite, so we must square root, and we must square root. Now that we have square rooted, what is the thing which is left? We must write it's either a positive or a minus. We come to the third quadrant where the opposite is a y value, and it's on this y-axis, this side, it's negative. So we can conclude that therefore our opposite is going to be a negative, and square root of 144 is the 12. So it's a negative 12. If you write positive 12, whereas the y value is located in the negative area, then your answer will be wrong. So it's very important for you to check where are you located before you determine the sign of the final number, right? So we found negative 12. However, we now can answer sin squared. Now we say sin squared theta is equal to, my opposite, I found it, it's negative 12 over, the hypotenuse is already provided, which is 13, and all of this is squared, which is equals to, I can even write therefore this side, negative 12 squared is equals to 144, and 13 squared is equals to 169. And just like that, I get my full marks, 3 full marks. Now, they want the value of tan 360 minus theta. You must not forget they said without using a calculator. You use a calculator, it's chai. Now, tan 360, tan 360 degrees minus theta. We are in quadrant number 4, and we said earlier on, in quadrant number 4, what happens? Cos is positive, which means that this tan is a negative. So we come here, we say that we are going to be dealing with a negative tan theta. So what is the negative tan theta? Now, what are we using? We're using these values, but we happen to be in the 4th quadrant. Now, when you are using tan, what do you say? You say opposite over what? Over adjacent. What is the opposite here? Our opposite, we found that it is negative 12, and in this quadrant it's to be negative 12. So we've got a negative 12 all over the adjacent. What is the adjacent? In this quadrant, your adjacent is 5. Let me just do this. So here we've got a negative 12, but here the adjacent, the x-axis is now positive. So we've got a positive like this, right? Which now gives us a negative 12 over 5. That's your final answer for tan 360 minus theta. Negative 12 over 5, that's your final answer, right? All right. Now we're going to cos theta minus 135. It has got 4 marks, right? Welcome to grade 12. Now, what are we going to do in this particular instance? The moment I get that, I now know that I'm going to say what? If I've got cos open bracket theta minus 135 degrees, I know that the first thing, it is equals to what? Cos theta multiplied by cos 135 degrees. My sign here is saying negative, so it changes to positive. Then I say sine theta plus multiplied by sine 135 degrees. Okay, then what am I going to do next? Now I'm going to repeat writing cos theta. However, as for my cos 135, I want to work with the reference angle. Where do I find this 135 degrees? I find 135 degrees in quadrant number 2. Which reduction formula is used in quadrant 2? It's 180 degrees minus theta. So here now I come and I say cos open bracket 180. For me to get 135, I subtract by 45 degrees, close bracket, plus, right? Let me just adjust my camera. All right. Plus sine theta multiplied by open bracket sine. Also, it's in quadrant 2. We say 180 minus 45 degrees. Right? All right. Now, on the next stage, we now say cos theta multiplied by, now I get cos 45 degrees plus sine theta multiplied by sine 45 degrees. All right. Now, let's revisit this fact that we are in quadrant number 2. In quadrant number 2, is your cos positive or negative? Remember the cast diagram, we say that sine is the only one which is positive there. So, which means this is a negative value. But what is our cos theta? Remember, we said our cos theta will give a negative 5 over 13, right? So now we come here, we substitute, and we say we've got negative 5 over 13, which is our cos theta, multiplied by our cos 45, we're negative there, so it's a negative. What is cos 45? We're now going to use the angles, triangles of special angles, right? So I'm going to use an isosceles triangle. And my isosceles looks like this. 1 square root of 245. I have got adjacent over hypotenuse, which is negative 1 over square root of 2, plus my sine theta. What is my sine theta? Now I say my sine theta is equal to I come here, my opposite, remember it's negative 12, my hypotenuse is 13. So I've got negative 12 over 13 multiplied by sine 45 degrees. Sine 45 degrees, now I say opposite over hypotenuse, which is 1 over square root of 2. And why did I choose that? Because remember, in quadrant number 2, what happens? In quadrant number 2, our sign happens to be positive, right? All right, that's why I chose it like that. Now, let's continue. As I continue now, I must multiply these two. So now I've got a negative multiplied by a negative, it gives me a positive. So 5 multiplied by this. There is something else which you can do if you don't want to complicate your life. So let me repeat writing negative 5 over 13 multiplied by negative 1 over square root of 2. What do I want to do? I don't want to work with this irrational number. So I'm going to rationalize the denominator. I'm going to use the conjugate, square root of 2 over square root of 2 plus. What do I mean when I say rationalize the denominator? I just want to work with a natural number, so I don't want to work with this side. All right, so now I say, here I'm supposed to put a bracket because I can't write that. Okay, negative 12 over 13 like this. And then I come and I do the same thing. I don't want to work with a side, so I multiply by a conjugate of square root of 2 over square root of 2, right? Now here, now I say I've got negative 5 over 13 multiplied by negative times positive, that's a negative. 1 times square root of 2, that's square root of 2 over square root of 2 times square root of 2, it gives me square root of 4. And what is square root of 4? It's a square root of a perfect square. It gives me 2. Now I've made it to be a natural number. Plus here, plus here I repeat writing negative 12 over 13. Then I say it's still going to multiply by 1 times square root of 2, I've got square root of 2 over square root of 2 times square root of 2, square root of 4. Square root of 4 is equals to 2. There we go. Now that I've done that, now these two must multiply. Now I can say negative multiplied by negative, it's a positive. 5 multiplied by square root of 2, I get 5 square root of 2 here, all over. Then when I say 13 times 2, that's 26. I've got 26 here. I still have got this positive sign. Negative times positive, it gives me a negative. So I open the bracket, I place a negative here. 2 multiplied by square root of 12 multiplied by square root of 2, it gives me 12 square root of 2 all over. 13 multiplied by 2, it gives me 26. Now I must multiply a positive times negative, it gives me a negative. So in other words, I've got 5 square root of 2 all over 26 minus 12 square root of 2 all over 26. Voila, now I've got identical denominators. I don't have to worry here. The alternative method would have been a little bit more complicated because a lot of people, they forget the 3 types of rationalizing the denominator. So that's why I chose the easier one. Now, when I'm here, I now know that since I've got identical denominators, I write a single denominator like that. Now I've got 5 square root of 12. 5 square root of 2. What's wrong with me? 5 square root of 2 minus 12 square root of 2. Because the square roots are identical, square root of 2 and square root of 2, it's basically saying 5 minus 12, which is negative 7 in this instance. So now we've got negative 7 square root of 2 all over 26. And this is our final answer. Owenzas klar. Now we go to the last, we are left with 2 more questions, right? Hopefully everybody understood what I did there. If you didn't, please just rewind, go back and watch again. Now, I would like you to pause the video and attempt these 2 questions before you see how I attempt them, right? Because they're 10 marks, actually. So here on 5.2, they say that you must simplify the expression to a single trigonometric term, right? What are we given? We're given 2 cos, open bracket, 180 degrees minus x multiplied by sine, open bracket, negative x. This is a negative angle. That's what it represents. Now we've got 1 minus 2 cos squared, open bracket 90 minus x. People, please learn about corratios and how they work, right? Learn about your reduction formulae. Even if you don't get out of these 6 marks, if you do not know the latter stages, just knowing your corratios and your reduction formulae, out of 6 marks, you can be guaranteed that you get 3 marks. So learn corratios, learn your reduction formulae. All right. Now, here we're given that we've got 2 cos 180 minus x, right? What happens with 180 minus x? In which quadrant am I? Let's come back again. 180 degrees minus theta, it means I'm in quadrant number 2. And in quadrant number 2, which trig ratio is positive? Sine, which means this cos is negative. So now I write is equal to 2 my negative cos x. Why? Because in quadrant number 2, this cos is negative. And then this negative, we now bring it here. We say negative sine x, like this negative angle. All over, we are now told 1 minus. Here we've got what? The cofunction 90 degrees minus x. What do we know? In this first quadrant, right? Oh, sorry. Let me write it here. In this first quadrant, what do we have? We've got sine, which is 90 minus theta. The moment you find 90 minus theta, guess what? You turn it to cos x. And the moment you have got cos, open bracket 90 minus theta, you turn this into a sine x. That's what we mean corratios or cofunctions. That's why I'm saying study this. Because what we have here, 90 minus, it has to be turned to a sine x. But we are told that it's cos squared. So which means that we now say 2, we turn this cos squared into a sine squared x. Right? Hopefully you have understood what I meant. All right. Now, what do we get? Here now we come and we say negative times negative, it gives us a positive. So now we have got 2 cos x multiplied by sine x all over 1 minus 2 sine squared x. This is a double angle, so it turns into cos 2x. And this 2 cos x multiplied by sine x, it's also a double angle, it turns to sine 2x. So now we've got sine 2x all over cos 2x. If you remember, what was the instruction? Simplify the expression to a single trigonometric term. Sine 2x over cos 2x, we are having tan 2x here, which is equals to, remember, your quotient identity. Sine over cos is tan. So we've got tan 2x. We've made it to be a single trigonometric term, tan 2x. And just like that, we are done. Then you get your 6 marks. 6 easy marks when you know your story. When you don't know your story, as you say, I'm at 2,000. It's chai. Now, let's go to the last question. The last question is intimidating, to say the least. However, let me prove it to you that it's actually not that intimidating. It just needs you to apply your mind. Now, we are told that calculate the value of the following expression without using a calculator. We are given tan 92 degrees, tan 94, tan 96, tan 176, and later on tan 178. What did I just say? We spoke about a quotient identity. What is the quotient identity? Quotient identity is when you say tan is equals to sin x over what? Over cos x. So all of these tans, I must change them to become sin x over cos x. So here I've got tan 92, which means that I come here and I say sin, okay, you can't see, it's out of the frame. Sin what? We say sin 92 degrees all over cos 92 degrees. They are multiplying, and then I've got sin 94 degrees all over cos 94 degrees. They are multiplying. Then here I've got sin 96 all over cos 96. First step, dot dot dot, my ellipsis, and then I say sin 176 degrees all over cos 176, right? And last but not least, sin 178 all over cos 178. People, just for doing this, just for knowing quotient identity, 1 mark. Simple, just rewriting, 1 mark. All right, what do we do now? Here, now that we're at this stage, remember, what do we have? Our Cartesian plane. What do we know about our Cartesian plane? We now ask ourselves the question, where do I get 92 degrees? I get 92 degrees in this second quadrant. In this second quadrant, what happens? What happens is that I have got 180 minus theta, right? Or if I've got co-ratios, your sine and your cosine, you say sine 90 degrees plus theta, you convert this sine to become a what? A cos x or a cos theta. And here, if you are having cos, open bracket 90 degrees plus theta, you change it to become a what? A sine. But cos is negative here, so it becomes a negative sine x. So amongst these two rules which I have in here, which one am I going to use? I'm going to use the co-functions here, right? So which means that here where I've got sin 92, now I say sin, open bracket 90 degrees plus 2 all over cos 90 plus 2 degrees. People, just for knowing these co-ratios, what I'm writing here, it's another mark. Out of the 4 marks, you are now getting 2 marks. Just by knowing the rules. Just because you know the rules, right? So let me just adjust the frame of my camera so that it can be legible. I do not know for how long was it not legible. Sorry for that. All right. All right. So I've got brackets here. Then I've got sin 90 plus 4 degrees all over cos 90 plus 4 degrees. Now, for these last two, observe, I'm given 176, right? So 176, I'm not going to use 90 plus. What am I going to use? I'm going to use 180 minus theta. So which means here I now come and I say sin, open bracket, 180 minus 4 degrees, which will get me to there, all over cos 176. I say 180. Or I could have continued with that 90 plus something, which would give me that. All right, 180 minus 4 degrees. And then last but not least, for me to get to 180, if I'm at 178, it's 2 degrees. So sin 180 minus 2 degrees all over cos 180 minus 2 degrees, right? I'm done, right, with getting my second mark. Now observe, remember, when you're using the reduction formulae, you need to use what? You use your acute angle for your reference angle. So here now I come, I had sin 2 degrees, but this sin 2 degrees, I now change it, it becomes what? Like I said, the ratio, it becomes cos 2 degrees. Remember, in the second quadrant, sin is positive. However, this cos, I have to change it to become what? To become a negative sin 2x, because in the second quadrant, cos is negative, right? Multiplied by, here the sin, I change it, it becomes cos 4 degrees. Here I change it, it becomes a negative sin 4 degrees, multiplied by, here I change it, it becomes sin, it becomes cos 6 degrees all over negative sine 6 degrees, multiplied by, then there I change it to become cos 4. Right, am I doing the right thing? let's just pause. If I say sin here, yes, so I must write sin because I used the reduction formula 180 minus. So now I say sin what? Sin 4 degrees over cos what? Cos 4 degrees. I don't change it because I didn't use 90 plus. No, I used 180 minus, so I can't change here. Then multiplied by, last but not least, sin 2 degrees all over what? 100 and cos 2 degrees, right? But is there anything that I have forgotten here? No, I didn't forget anything. Now, observe one thing. When we started with the first 3 terms, we were moving from 2 degrees, 4 degrees, 6 degrees. What was happening with the values? They were increasing. However, when you get to this part, now you've got sin 4 degrees, sin 2 degrees. What's happening at the later stage? They are now decreasing. What kind of story are we hearing here? The kind of story that we have here, it's a story which tells us that our values from a certain number, let's say from here to somewhere there, they were increasing. And then there's a point whereby they moved from and they started to decrease. So what do we need to find out? What we need to find out is the fact that how many values do we have here, right? So if I'm moving from 92 and I end up getting to 178, how many values do I have in between, right? Right? Yes. So how many values do I have in between here? If I move from 92 to 178, what can I do? 2, 4, 6. I can use my arithmetic just to figure out, right? Because I'm having a constant difference of 2, 2, 2, 2. It was increasing by 2. So I can say Tn is equals to A plus open bracket n minus 1 close bracket D. Now I'm saying Tn is equals to the first term that I have is 92 plus open bracket n minus 1 close bracket 2. Then what do I have? Now I say Tn is equals to 92. 2 by this, it gives me positive 2n and minus 2. And this 92 minus 2, it's Tn is equals to 2n plus 90. Now I was at 178. If I say 178 is equals to 2n plus 90, and I say 178, I transpose, it becomes negative 90 is equals to 2n. Now, I say, let me put it like this, 178 minus 90, 8 minus 0, that's 8. Then 10, 11, 12, 13, 14, 15, 16, 17, I've got 88. So I've got 88. 178 minus 90, it's 88. I've got 88, which is equals to 2n. I divide by 2, I divide by 2. Therefore, 88 divided by 2 is equals to 44. Which means that from sin 92 to sin 178, I've got 44 values. What is the importance of this? The importance or the relevance is that this is an even number. So why do I want to know about the even number? Because it means out of the 44 values that I have, at the half mark, let me just erase here so that it can make sense. I've got 44 values, and from here I'm saying that at the half mark, our values from the first value to the 22nd value, they were increasing. And then from the 22nd value to the 44th value, our values were decreasing. Right? Okay. So, what does that mean? Observe one thing. Here now, it means that, why am I concerned about that? Because I've got these negatives. That's why I wanted to know how many values do I have. I want to know that, am I going to have a negative answer or a positive answer? So remember, when you've got even numbers, when you say -1 multiplied by another -1, your sign will be a positive. So you have a +1, right? But if you are to have odd numbers, -1 multiplied by -1 multiplied by -1, negative times negative, positive times negative, it's a -1. So because 44 is an even number, it means these negatives, they are going to cancel out. We will get a positive answer. Now, how are we going to cancel out, you might ask? We are now going to cancel out like this. Observe, here you have got negative sin 2, right? And on the numerator here, you've got sin 2. So they cancel out. You have got cos 2 degrees here. It cancels out with this cos 2 degrees. You have got negative sin here. It cancels out with this. You have got this cos 4. You have got that cos 4. So if we had written a value here, remember I said it is what? Decreasing. So which means that here it would have been a what? A sine 6 degrees over a cos 6 degrees. This sine would have cancelled with that sine, and this cos would have cancelled out with that cos. And since all the values are equal to each other, we can conclude that, remember, when you are cancelling, you leave 1, 1, 1, 1. So 1 multiplied by 1, and those negative ones multiplied by negative ones, they'll give us what? 1. And your final answer is equals to 1. And just by doing this, then you get your 4 full marks. And just like that, voila, you are done. Right. So the basics, when we say that focus on the basics, we are not kidding. They mean something. They help you to get full marks. If you found this video to be helpful, please do consider subscribing. And then on the next video, I'm going to be dealing with what? The higher order questions of this past exam paper. This question paper was written in June 2025. It was a DBE, Department of Basic Education paper. Till we meet next time, cheers.